Okay, so this is question 6A from the 2021 special exam. The maximum load is 1,000. The masses of employees, user left and normal distributed of a mean of 75 and standard deviation of 8. Now, when we have a lift, we have our people in the lift and they're all separate, so they're all independent of each other. So I'm suggesting that the total is going to be participant 1 in the lift plus participant 2 in the lift, all the way up to the nth in the list. So the expected value of the total weight in the lift would be n lots of expected value of P, which is going to be 75n. And that the variation of the total will be 1 squared times the variation of P1 plus all the way up to 1 squared times the variation of the nth person, which is going to give you n lots of the variation of P, which should be, that's the standard deviation, so 64n, or the standard deviation of T should be 8 root n. Now we're wanting the probability that the total is exceeded 1,000 is to be less than 0.01%. That's what we're after. And we've got to solve for n. Now we have from 15a, this is the expected value of t, where t is n lots of p's being added together. So I'd like to use the normal distribution because I've got t at the moment. 75p is the mean. There is 1,000. I want that to be 0.01. So I'm wanting the probability to be to the left of it. So if I could use the z-score and do a right tail on the z-score, it gives me a right value of 0.01, and then compare z equals 1,000 minus 75n on top of 8 root n, and compare that to whatever that z-score there is. So that gave me a z-score of 2.326. And when I go 2.326 equals the right-hand side, that gave me n equaled 12.45. Now, I know that if I have 13 people in the lift, the probability of it exceeding 1,000 is going to be greater. Therefore, I need 12 people for the probability to be less than 1%, because obviously if I jump to the 13th person, the probability of being greater than 1,000 increases, not decreases.